Hello and welcome to a new video on IGCSE Mathematics. In this video, we shall be discussing motion graphs and we shall be dealing with advanced problems. The diagram shows the speed time graph for 120 seconds of a car journey. Calculate the deceleration of the car during the first 20 seconds. So during the first 20 seconds, this means that we are dealing with this point and this point. These are the initial and final points on the graph. Remember our model. You should have watched the basic and intermediate videos on motion graphs before attempting to watch the advanced video. So our model was acceleration, velocity, and displacement. We start where the title of the graph is. So the title of the graph is speed time graph. So this is speed. So therefore, we're going to start at V. We are required in A to get the deceleration. So deceleration is derived from acceleration. So we're moving towards acceleration like this. And since we're moving down, we are required to get the slope. So therefore, here we are required to calculate the slope between these 2 points. So let's first write down the points. The points are 0 and 18 for the first one. And for the second one, the coordinates would be 20 and 10. Now to get the slope, we need to label them. So let's just say that this is x1, y1, and this is x2, y2. And we can get the slope as y2 minus y1 over x2 minus x1. So m equals y2 minus y1 over x2 minus x1. So y2 is 10, y1 is 18, x2 is 20, x1 is 0. So we have negative 8 over 20. And this is the same as negative 0.4. So the acceleration is negative 0.4. So the deceleration would be positive 0.4 because deceleration is the negative of acceleration. The unit here, of course, is meters per second squared. You should know this as well. So this is our final answer. Calculate the total distance traveled by the car during the 120 seconds. So now we need to get the distance. And again, we're starting at V because this is a speed time graph. And you want to get X, which is the distance. So we need to get the area under the graph. So this is a more complicated graph than what we are used to dealing with because you cannot describe it as one shape only. You have to split it into different shapes and get the area of each. So I'm going to split into 3 shapes like this. So we have the first shape here is shape A. Let's call this shape A. And then we have shape B. And we have shape C as well. A and C are trapeziums, and B is a rectangle. We want to get the area of each in order to get the total area. So let's just get area of A, area of B, and area of C. I'm going to start with the simplest one, which is B, because the rectangle is easier to figure out. So B lies between 20 and 90. So the width here is 70. And the height or the length of B is this distance here, which is 10. And the area of B is basically length times width, which is 70 times 10. And this gives us 700 meters. Now, A and C are trapezoids, but they are vertical trapezoids in the sense that their parallel sides are vertical and not horizontal. So the base of the trapezoid does not necessarily have to be a horizontal line. Essentially, you have two types of trapezoids. This is a horizontal trapezoid in a sense, and this is a vertical trapezoid. The idea is that the bases are the two parallel sides, so B1 and B2. Here they're horizontal, but here the parallel sides are vertical. So B1 and B2, the bases are vertical lines, not horizontal lines. Of course, the other two sides are not parallel at all. So in our case here, we're going to label this line as B1, and we're going to label this line here as B2. And we can write down the formula of a trapezium, which is half B1 plus B2 times height. So B1 is the first vertical line, which is 18. So let's write that down as well. So we have 18 plus, and then B2 is 10. And then the height would be the line joining both bases. It has to be either horizontal or vertical. It's not the diagonal line, definitely. So it has to be this line here. It has to be perpendicular on both bases. This would be the height. And the height in the first case is 20. So we can write that down as well. And if we multiply, here we have 28. So half times 28 times 20 is 280 meters. Finally, we want to get the area of C. Like we said before, C is a trapezium as well. So the same rule applies. Half times B1 plus B2 times the height. And again, B1 and B2 are the parallel sides. This would be B1. This would be B2. And the line joining both and perpendicular onto both, this here would be the height. So B1 is equal to 10. Let's start plugging in the values. So B half, of course, first, and then B1 is 10, and B2 is 20. And the height is the distance between 90 and 120. So this here starts at 90 and it ends at 120. So the distance between them is 30. So therefore the height here would be 30. And then we multiply them by each other. We get 450 meters as a final answer. Now to get the total distance, we add these three distances up. So the distance equals 280 plus 700 plus 450. You can use your calculator to figure this out. So 280 on the calculator plus 700 plus 450. This gives us 1,430 meters. And this is the final answer to question B. For C, we're required to calculate the average speed for this 120-second journey. So average speed is total distance divided by total time, which is 1,430 divided by 120. And this gives us 11.91. So just 11.9. And the unit here would be meters per second. Now let's check the marking scheme to compare the answers. So 0.4 is correct, 1,430 is correct, and 11.9 is correct as well. The diagram shows information about the first 100 seconds of a car journey. Calculate the acceleration during the first 20 seconds of the journey. I'm going to move a little bit faster now. You're probably used to the same technique being repeated over and over again. So acceleration here is the slope. we have 0, 0, and 20, 16. So it will just be 16 minus 0 over 20 minus 0, y2 minus y1 over x2 minus x1. And we get 16 over 20. And this is equal to 0.8 meters per second squared. Next, we want the total distance traveled. And again, we said the distance here is the area. So we split again into three shapes. Shape A, shape B, shape C. And we get the area of each. So the area of A is a triangle, so it's just half times base times height. The base is the horizontal line here, which is 20. And the height would be the vertical line, which is 16. So I would just write half times 20 times 16. And this would equal 160 meters. Next, we want to get the area of B. B is a trapezoid again, but it's a vertical trapezoid. The parallel sides are vertical, so the bases here are vertical. This would be base 1, this would be base 2, and this here would be the height. The formula for a trapezoid is half times B1 plus B2 times height. So B1 from the graph would be 16, B2 would be 12, and the height is the distance between 20 and 50 on the x-axis. So from 20 to 50, this is 30. So we have half times 28 times 30. We can use the calculator for that. You get 420 meters as a final answer. Finally, we want to get the area of C. C is just a rectangle, so this is just length times width. The length goes from 50 to 100, so it's 50. And the width or the height goes up to 12. So I'm just going to multiply 50 by 12. If you don't understand where this came from, I got 50 from here. I did 100 minus 50, and that gave us 50. And 12 minus 0, which is 12. So I just multiplied 50 by 12, and this gives us 600 meters. Therefore, the total distance traveled is going to be the sum of these three numbers, 160 plus 420 plus 600. And you can use your calculator for this. You get 1,180 meters in total. So let's just put circles around the final answers to compare to the marking scheme. So 0.8 is correct, and 1,180 is correct as well. The diagram shows the speed time graph for 90 seconds of a journey. Calculate the total distance traveled during the 90 seconds. Again, this is advanced because this graph consists of multiple shapes. This is the first shape here, and this is the second shape. We're going to call this A, we're going to call this B, and we're going to get the area of each. So A is a vertical trapezoid. The parallel lines are vertical, so this would be B1, this would be B2, this would be the height. For B, this would be the length, L, and this would be the width or the height, W. And now we can proceed to write down the equations and figure things out. So the area of A is half times B1 plus B2 times height. B1 is equal to 6, B2 is equal to 12, and the height is between 0 and 30, so it's equal to 30. So half times 18 times 30, and we can use the calculator for this. We get 270. Then we want to get the area of B, which is a rectangle. So the area of B is length times width. And we said that the length L, so L goes from 30 to 90, so L is 60. And the width goes from 0 to 12, so this would be 12. So 720. And then we add these two numbers up together. So 720 plus 270 gives us 990 meters, and this would be our final answer. 990 is correct. The diagram shows the speed time graph for part of a journey for two people, a runner and a walker. Calculate the acceleration of the runner for the first 3 seconds. So the runner accelerates from this point to this point. Here we have 0 and 1.2. Here we have 3 and 3 as well. So the slope would be 3 minus 1.2 over 3 minus 0, which is 2.8 over 3. Excuse me, this would be 1.8 over 3. So therefore, the answer would be 0.6 meters per second squared for A. For B, we are required to calculate the total distance traveled by the runner in the 19 seconds. So again, we have to split into 3 shapes. This is shape A, and this is shape B. Remember, the distance traveled by the runner is the area under the runner's graph, regardless of the walker. So you don't just calculate the area between the runner and the walker, you calculate the whole area under the runner's graph. So this whole shape is B, and then this shape here would be C. So A and C are trapezoids, but B is a rectangle. We get the area of each like we did before. I'm not going to write the rule down. I'm just going to fill in the numbers. So half times B1 plus B2. B1 is 1.2 and B2 would be 3. And the height here would be 3. Of course, this here is B1 and this here is B2. And the distance between them is the height. So you can multiply these out. Of course, this is 4.2 here. So you get 6.3. B is a rectangle. The length of the rectangle lies between 3 and 15. So this is 12. And the width of the rectangle goes from 0 to 3. So this is 3. So we just have length times width, which is 12 times 3, which is 36. For C, we have a trapezoid again. So this is B1, this is B2, and this is the height. So we just have 1 over 2 times B1, which is 3, plus B2, which is 1.2, multiplied by the distance, which is 4. So you can use your calculator. Calculate this. 3 plus 1.2 is 4.2. Half times 4.2 times 4 would be 8.4. So the total distance traveled would be the summation of these 3 numbers. We have 6.3 plus 36 plus 8.4. We can use these, we can add them up, and we can find the total distance. So 6.3 plus 36 plus 8.4 gives us 50.7 meters. In C, we are told the runner and the walker are traveling in the same direction along the same path. When t equals 0, the runner is 10 meters behind the walker. Find how far the runner is ahead of the walker when t equals 19. So the distance traveled by the walker is the area under the graph of the walker, which I'm now shading in green. This is the distance traveled by the walker. So it's a rectangle. The length is 19 and the width is 1.2. So we can just calculate the distance of the walker. D equals 19 times 1.2. length times width of the rectangle in green. So 19 times 1.2 gives us 22.8. So this is the distance of the runner. So the difference is 50.7 minus 22.8. This is how much more distance the runner covered than the walk. So 50.7 minus 22.8. This gives us 27.9. So the difference between them is 27.9 meters. But the walker was initially 10 meters ahead of the runner. The runner is 10 meters behind the walker. So we want how far the walker is ahead, how far the runner is ahead. So the runner will now be ahead by 27.9 minus 10, which gives us 17.9 meters as a final answer, because we have to remove the 10 meters that the runner needed to cover in order to catch up with the walker to begin with. So now let's just circle the answer to part A as well to compare to the marking scheme. So 0.6 is correct, 50.7 is correct, and 17.9 is correct as well. The speed time graph shows information about the train journey. By drawing a suitable tangent to the graph, estimate the gradient of the curve at t equals 24. So let's draw a tangent to the graph. So I'm going to try to draw a decent line, but this is going to be a bit difficult because I'm writing on the screen. But so that you would get the general concept, we want to draw a tangent when t equals 24. So t is 24 here. So we want to draw a tangent at this point right there. So this point, we can get the y coordinate of it. Or we don't even have to get the y coordinate. Let's first just draw the tangent line. So it looks something like this. It's not a great line. However, you should be able to draw a better line using your own ruler. So we can get this point here. This seems to be a clear point. And we can also get, for example, this point right there. It's better to take 2 points that are far away from each other to get a more accurate result. So let's write down the coordinates of these points. So here, this would be 26. We have to move 2 boxes per unit. So this would be 27. So the x value here is 27. And the y value is 1, 2, 3. So 4 boxes up from 0. We can check the scale on the y-axis. So on the y-axis, these are 10 boxes. So this here, this here would be 0.4, 4 boxes up. So we can write down the y value as 0.4. And then for the other point, we're going to repeat the same process. Here, the y value is quite obvious. It's 2 because it lies on one of the main big lines. So the y value here is 2. The x as well is obvious because it lies right in the middle between 20 and 25. So it's 22.5. Now we can get the gradient of the tangent by subtracting. So the slope will be 0.4 minus 2 divided by 27 minus 22.5. So 0.4 minus 2 on the calculator. I'm just going to write 0.4 minus 2 in the numerator. And in the denominator, I'm going to write 27 minus 22.5. The answer I got was negative 0.3555. So negative 0.3555. 5, 6. Of course, this is an estimation, and like I said, because I'm drawing on the screen, not using a ruler, my tangent was not very accurate. I just did the best I could, but my point is that you need to learn the technique of how to draw a tangent. So you need to draw a line that touches the curve at the point that they requested, and they requested to have the tangent at t equals 24. So you have to check where this point is on the graph. And this point is here, because this is where t equals 24. And you have to draw a tangent at this point, which is what we attempted to do. Let's check what the actual answer is. So, excuse me. So anything between negative 0.7 and negative 0.3 would be counted correct. And our answer is actually negative 0.356. So our answer lies within the correct margin, even though I did not draw it very accurately. But this tells you that they have a very wide region for you. Even if it's not exactly accurate, you can still get the right answer if you follow the correct steps. But my advice is always use 2 points that are very far away from each other. So I did not attempt to use the actual point here, even though this is the point that they requested. I instead chose 1 point above it and 1 point below it so that we have a good enough distance between the 2 points. So anyway, for B, we are required to state what this represents. What does this gradient represent? So this gradient is actually y2 minus y1 over x2 minus x1. So in a sense, it's y over x. Y here is the speed, and x here is the time. So speed divided by time gives us acceleration. This is if you don't remember what the gradient is when we have a speed time graph. If you want to memorize it, you have a model where you have acceleration, velocity, and displacement. We start at the letter which corresponds to the title of the graph. So this is a speed time graph. So we start at speed, which is v. And we want to get the gradient. So gradient means we're moving down. So slope or gradient means we're moving down. So the result or the answer is acceleration. So either using the equation or using the model we discussed before, either way, you can figure out that this represents the acceleration. Work out the distance traveled by the train when it's traveling at a constant speed. So the distance traveled is the area under the graph. And the area under the graph here is quite simple because when it's traveling at a constant speed corresponds to when the line is horizontal. So we just need to get the actual area. And you can see here that this point is 4 boxes away from this line here. So after 20, we move 4 boxes, and each 2 boxes count as one block, as one unit, I mean. So this would be 21, and this here would be 22. So the coordinates here would be 22 for x and 4 for y. And on the left, this is quite simple. This is 5 and 4. Of course, the bottom 2 are quite easy now to figure out. This would be 5 and 0. And this would be 22 and 0. So the distance horizontally goes from 5 to 22. So this is the distance here. And this is 17. And the distance vertically is 4. So the area would be 17 multiplied by 4. And this would give us 68 as a final answer, or 68 meters. This would be the final answer for C. We already verified A, and for B, acceleration is correct, deceleration is correct. For C, 68 meters is correct as well. The diagram shows the speed time graph for 70 seconds of a car journey. Calculate the deceleration during the first 20 seconds. So during the first 20 seconds, the deceleration lies between these 2 points. We have here 0 and 16. We have here 20 and 10. We want to get the deceleration, so it's basically the slope. It would be 10 minus 16 divided by 20 minus 0. This gives us negative 6 over 20, which is negative 0.3. So the deceleration will be the positive value of this number, 0.3 meters per second squared. Calculate the total distance traveled by the car during the 70 seconds. So now we need to get the area under the graph. Here we can divide it into two shapes. The first shape would be this trapezium here. And the second shape would be a rectangle. So for the trapezium, this would be B1 and this would be B2. And this distance here is the height. And for the rectangle, this distance here is the length. And this distance here is the width. We can call this A, we can call this B. We get the area of each. So the area of A would be half multiplied by 16 plus 10 multiplied by the height, which is 20. This would be 26. So the answer would be 260 meters. For B, we have length times width, L times W. And the answer here would be 70 minus 20 would be 50. So L would be 50. And the width is basically the height, which is 10. So 500 meters. So the total distance would be the sum of these two numbers. 260 plus 500 gives us 760 meters as a final answer. You can circle the final answer here as well. And we can proceed to compare to the marking scheme. So 0.3 is correct and 760 is correct as well. Next, we move on to problems where the speed or the time are unknown. The speed time graph shows the first 30 minutes of another train journey. The distance traveled is 100 kilometers. The maximum speed of the train is V. Find the value of V. So this is slightly different from what we did before because the speed here is unknown. So in this case, this is the height of the trapezium and we do not know it because this value is the same as this value, of course. So we are given that the total distance is 100 and the total distance here would be the area. So the area is half B1 plus B2 times height. And all of this is equal to 100. The height here is represented by the letter V capital, and we do not know V capital. That's what we're trying to get. And then we want to get B1 and B2 as well. So B1 and B2 are quite simple. These are the bases of the trapezium. Remember here that the speed is in hours, kilometers per hour. So we have to get the values in terms of hours. So here we have from 6 to 6:30. So the difference is 30 minutes. So 30, but over 60 because we want to convert it to hours. And then from here to there, we want to go from 0.5 to 25. So that's 20 minutes. But again, we have to divide by 60 to convert to hours. So we can write this as 20 over 60 and 30 over 60. And now we have an equation, Now we have an equation where V is unknown. So half times 20 plus 30 over 60, that gives us 50 over 60 times V equals 100. So we multiply half times 50 divided by 60, we get 0.416667, or 5/12 as a more exact answer. So 5/12 times V equals 100. So V equals 100 divided by 5/12. You can, of course, use your calculator, or you can think of keep change flip. So 100 times 12/5. And this gives us 240. So the final answer would be 240 meters per second. Next, we want the acceleration during the first 5 minutes. We want the answer in meters per second squared. So there are some unit conversions here. First of all, to get the acceleration, we need to understand that we are getting the slope between these 2 points. But the problem is that the time here, if we calculate it here, this is 5 minutes. And the speed here is in kilometers per hour. So in order to get the acceleration, we need to make sure that we have the same units. So instead of 5 minutes, since we want it in seconds, we're going to multiply it by 60. So this gives us 300 seconds. And then for the speed, we know that it's 240. Excuse me, so this was a wrong unit here. I apologize for that. This was supposed to be kilometers per hour. But we now want to convert it to meters per second, actually. So 240 kilometers per hour means 240 kilometers over 1 hour. And we want to convert it to meters per second. So we multiply here by 1000 and we multiply here by 60 twice. So we get 240,000 divided by 3,600. So 240,000 divided by 3,600 gives us 200/3. So V equals 200/3 meters per second. So now that we have the value of V, we can rewrite this point here in terms of time and speed. For time, we said that the value is 300. We got that by multiplying 5 minutes by 60 to get 300 seconds. So the time here is 300 and the speed here is 200 divided by 3. Now we can get the slope. Since, of course, the other point here is just 0, 0, we can get the slope as 200/3 minus 0 divided by 300 minus 0. So this is 200/3 divided by 300. You can use your calculator to figure this out. You get 2/9 meters per second. 2/9 meters per second squared. As a decimal, it's basically 0.222 meters per second squared. So 240 is correct, and 2/9 is correct as well. A car starts from rest and accelerates for u seconds until it reaches a speed of 10 meters per second. The car then travels at 10 for 2u seconds. The diagram shows the speed time graph for this journey. Distance traveled by the car in the first 3u seconds is 125 meters. Find the value of u. So the distance traveled in the first 3u seconds is 125 meters. And this is represented on the graph as the area under the graph. So this area here gives us the distance. So how can we get this area? This is a trapezium. So we can write the rule for a trapezium. Half times B1 plus B2 multiplied by height. So B1 here would be 3u. This is the denominator. Excuse me, this is the bottom base, I mean. This is this distance here. This is 3u. And then for the top base, this would be 3u minus u, which would be 2u. So 3u plus 2u. And then the height would be 10, as given on the graph. So half times 5u times 10. And this is equal to 125. Of course, we can multiply half by 5 by 10, and this gives us 25. So 25u equals 125. And then u becomes 125 over 25, which is equal to 5. So u equals to 5. And then you want to get the acceleration. Now this becomes quite simple because the units even here are matching meters per second with seconds. So we don't need to do any conversions. And we said that u here is 5. So the value at this point here is basically 5, 10. We can get the slope since the other point again is 0, 0. We can just use the slope formula, and that would be 10 minus 0 over 5 minus 0. And this gives us 2. So the answer would be 2 meters per second squared. And of course, 5 here, we can write seconds as a unit next to it as well. So 5 and 2 are the correct answers here. The diagram shows information about the first 8 seconds of a car journey. The car travels with constant acceleration, reaching a speed of v after 6 seconds. The car then travels at a constant speed of v for a further 2 seconds. The car travels a total distance of 150 meters. Find the value of v. Again, this is the same idea pretty much. The total distance is the area under the graph, and this is equal to half times b1 plus b2 times the height. b1 is the bottom base, which is 8. b2 is the top base, which is 8 minus 6. So this is 2. We got this by subtracting 8 minus 6. And then the height here is unknown, so we just write v. And then all of this is equal to the total distance traveled, which is given in the problem as 150. So half times 10 times v equals 150. So therefore, 5v equals 150. And you divide by 5, you get v equals 30. And 30 here is the correct answer. The diagram shows the speed time graph for the first t seconds of a car journey. Find the acceleration during the first 10 seconds. So for the first 10 seconds, everything is known. This point here is 0, 0. This point here is 10, 12. We want to get the acceleration. We get the slope. So 12 minus 0 divided by 10 minus 0. And this gives us 1.2 meters per second squared. In B, we are told the total distance traveled during the t seconds is 480 meters. Find the value of t. Like we said before, the total distance is the area. So area is half times b1 plus b2 times the height. Now, b1 here is unknown. It's the bottom base, so from t to 0. So this would just be t minus 0, which is t. And then the top base here would go from 10 to t. So this would be t minus 10. So we write here t minus 10. And the height is known as 12. So therefore, we have half times t plus t minus 10 times 12. And all of this is equal to 480. So we can multiply the half by the 12 just to get rid of all of this complication. So half times 12 is 6. And then inside the bracket, we have 2t minus 10. And this is equal to 480. You can either distribute the 6 over the bracket, or it would be smarter to just cancel out the 6 and divide here by 6. Because 480 is divisible by 6, it gives you 80. So now we have 2t minus 10 equals 80. So 2t equals 90. So t equals 45, and this would be your final answer. So let's just circle the final answer to A as well. So the answer to A is 1.2, and the answer to B is 45. These are both correct. So moving on to the final question in this video. The car travels at 20 meters per second for 15 seconds before it comes to rest by decelerating at 2.5 meters per second squared. Find the total distance traveled. So the problem here is that to get the total distance, we need the area, and to get the area, we have to have this value here of t. So how do we get this value? Here you need to use the logic of calculating or understanding what deceleration means. So deceleration means that the speed decreases by 2.5 every second, right? So the speed was initially 20. After 1 second, you subtract 2.5, so you get 17.5. And then after another second, you subtract another 2.5, so you get 15, and so on and so forth. How long will it take to reach 0? So the idea is that you want to finish, or you want to change the 20 into 0 by making jumps of 2.5. So how many jumps of those would you need? So this is the same as asking yourself 2.5 multiplied by what gives us 20? So the answer would be simply 20 over 2.5, and this would be 8. So if we subtract 2.5 8 times, the 20 becomes 0. And since we're subtracting 2.5 every second, this basically means that we need 8 seconds to reach 0. So this amount of time here is actually 8, and therefore t equals 23. How did I get 23? Of course, I added 15 and 8 together. Now that we have this value, it would be quite simple to figure out the distance, because the distance is the area. So it's half times base 1 plus base 2 times height. Base 1 is the 23. Base 2 is 15. And the height is 20. 23 plus 15 gives us 38. So half times 38 times 20. This gives us 380 meters as a final answer. So 380 here is correct. And this brings us to the end of our video. I hope this has been beneficial. Thank you for watching.